Hello guys, and welcome to Math Vantage. So in this lesson we are going to talk about the area under the curve using Riemann sum. Right? So this is the topic that we'll be talking about today, and then whenever we're using Riemann sum, it's either we're going to use the left hand point or the right hand point or the midpoint, right? So now let's say we're given an equation or example. Let's say example 1. It says find the area under the curve. Find the area under the curve using the right hand point. The right hand point, right? And then let's see, we are given function which is y is equals to x squared plus 1, right? And then we have the 2 points, which is 0 and 2, or you can call them limits. And then we have n, whereby mostly they can call it strips or the number of rectangles, right? So this is the information that we have, and we are asked to calculate the area under the curve using the right endpoint. So solution. So the first step, guys, that you need to do, okay, let me write it. First step, always whenever you're given this type of question, the first step that you need to do is to write that formula. The formula of calculating the area under the curve, it's area for Riemann sum, it's area is equals to sigma I is equals to 1 and delta x, or the width, multiplied by f of xi. This is the formula that we are going to use. In most books, you'll find that they have used k here, not I. So it is like they said, k is equals to 1. Therefore, from here, it was going to be, okay, let's do it. It was going to be f of xk, right? Can you see the difference? If it's k and then here, it's also going to be k. And then if it's I, and also here, it's going to be I. So let me erase those things. Okay guys, after writing the formula for the second step that you need to do, second step is to find delta x, or the width. What is the formula of finding delta x? The formula of finding delta x is delta x is equals to b minus a all over n, right? So what does b represent? B and a are this b and a represent our 2 points, which if you can check here, we have 0 and 2 here, which are the 2 points at the 2 limits. Therefore 0 represent a, the first value represent a, and the second value represent b. Hope you guys can see it. And what about n? N represent the number of strips or the number of rectangles. So you can see that we are given n. So now let's use this formula to find delta x. Therefore our b is going to be 2. What is a? A is going to give us 0 all over. What is n, which is the number of rectangles? it's gonna give us 0.5, right? So after getting 0.5, now we're going to the third step. What do we do on the third step? We draw a timeline or number line. We draw a number line. We draw a number line. How do we draw a number line? We just do a line like this, right? Therefore, the first value that we write here, it has to be the first point or the first limit. So we can see from our given information, the first point, which is a, is represented by what? It's 0, right? After writing 0, now, because remember the aim of calculating the width or the delta x, it was to add that delta x in the timeline until we arrive at 2, which is the last point. Also, we are going to say 0 plus 0.5. It's going to give us 0.5. And then again, 0.5 plus 0.5, it's going to give us 1. And then 1 plus 0.5 is going to give us 1.5. And then 1.5 plus 0.5 is going to give us 2. Right? So do we continue? No, we don't continue because the last point is what? It's 2. So meaning we have to stop here at 2. This is why most of the time you have to start finding delta x before you can do your timeline or number line, so that you can know which width you have to use and which size of width you need to use, yeah, like those kind of things. So now, after finding the number line or after writing out the number line, we are going to write down those values, right? We are going to write down those values. And before we can write down those values, that's where we check our question. Our question said find the area under the curve using the right endpoint, right? So whenever we use the right endpoint, this is what we are going to do on the fourth step. On the fourth step, we choose the values. We choose the values. So how do we choose the values? We check the question. What does the question require? So therefore we can see that the question requires us to find the area under the curve using the right endpoint. So whenever we're using the right endpoint, we start counting from the right going to the left, right? We start counting from the right going to the left. And remember, when we count, if you can count these numbers here, it's 1, it's 0, 0.51, 1.52. There are 5 numbers. But then we are not going to choose 5. Why? Because our n is equals to 4. So whenever our n is equals to 4, it surely tells us that we need to choose 4 values. We don't choose 5. Or what you can do, guys, you can see that we have 5 values here because of n is equals to 4. So whenever you're given to say like use the right endpoint, the values that you need to choose, you start counting from right up to 0.5. So therefore you leave the last one, which is 0. And then whenever you are asked to find the area under the curve using the left endpoint, we start counting from the left, which is 0, up to 1.5. We leave the last one, which is 2. That's how we do. So you have to always leave the last one. So if you're not given n, I'm talking about this, let's say if you're not given n, you don't know what is n, right? So even though you don't know what is n is, But then the numbers that you choose, you have to choose from here and then leave the last value and then just like that, right? So let's go back to the business. Now we said we choose the values. So how do we choose the values? Because it's the right endpoints, we're going to count from 2. We're going to have 1, 2, 3, 4. And then we leave the last one. Can you guys see it? We leave the last one, meaning we have 0 0.5, we have 1, we have 1.5, then we have 2. There are 4 numbers. We left 1. So if it was find the area under the curve using the left endpoint, we're going to count from, it's going to be 1, 2, 3, 4, and we leave the last one. So even though you don't count, you just know that if it's the left endpoint, I just have to leave the last number, counting from left going to the right, and then vice versa, right? So after choosing the values, that's where we're going to write our formula again. Our formula is equals to A is equals to delta X. Now we are going to replace that sigma and f of xi with f of x1 plus f of x2 plus f of x3 plus f of x4. Why do we write it like this? Remember, sigma represent what? To add, right? And then if you can check our f of xi here, it represent what? It means these are the values that we have. We don't know how many values we have, but then according to the n strips, it shows that we have 4 values. That's why we said it's from x1 to x4, right? And then we add, therefore, whenever we add it like this, we replace that sigma and f of xi with this one, right? So now, what if of f of x1? Remember the values that you choose, it means this represent this represent x1, this represent x2, this represent x3, this represent x4. We don't care about the or. You can start from 2 going to 0.5. You can say 2 is x1. We don't care about it because we are adding, so you're still going to get the same value, right? So now, what is the delta x? The delta x is equals to 0.5, right? Therefore, we have f of, what is x1? x1 is 0.5. What is x2? x2 is 1. What is x3? It's 1.5. What is x4? It's 2. Right. After writing it down like this, now that's where we are going to write our function. Remember, our function is y is equals to x squared plus 1. Right. We know that we can also write it as f of x is equals to x squared plus 1. Right. So now, where we see x, we are going to replace it with 0.5, 1, 1.5, and 2 and find the values, right? So let's start with f of x1. f of x1, okay, let me write it down. f of x1, we know that x1 is equals to 0.5, therefore it means we're going to have 0.5, therefore 0.5 squared plus 1, right? Therefore, now when we use the calculator, we're going to get 1.25. This is how we find the first value for f of x1. Therefore, f of x2, we do the same thing. It's x squared plus 1, right? Therefore, it's going to give us f of, what is x2? x2 is given by 1 is equals to 1 squared plus 1, which is going to give us 2. Can you guys see it? Then now we come to f of x3. f of x3 equals to x squared plus 1. Therefore, x3 is given by 1.5. Therefore, we're going to have 1.5 squared plus 1. 1.5 squared plus 1 is going to give us 3.25. Therefore, the last one, f of x4, which is x squared plus 1. Therefore, we know that f of x4 is what? It's 2. Therefore, it's going to give us 2 squared plus 1, which is going to give us 5. So now we are done. You can see that we have the values of f of x1, f of x2, f of x3, and also the last value for f of x4. And then now we can write those values, right? So let me just erase some few things here so that we can have space. Okay, so now we're going to this formula. We're going to write it again, which is a is equals to delta x into f of x1 plus f of x2 plus f of x3 plus f of x4. And now because of we know the values of f of x1, f of x2, then we're going to replace f of x1 with those values, right? What is delta x? We know that the value of delta x is 0.5. F of x1 here is it's 1.25, 1.25 plus f of x2 here is which is 2 plus f of x3 is 3.25, 3.25 plus f of x4 which is 5. Right. Therefore, we are going to have the final answer is going to give us 5.75. Because remember, it's the area, we're calculating the area. And then as we are not given the units, the SI units, what we can do here is to write units squared. Right. This is how we do it. This is the first video for finding the area under the curve using the right endpoints. So kindly subscribe and like if you find this video useful. Thank you guys.